Alright, we're going to try to find the slope of the inverse of f of x at x equals 3 for the function f of x is x cubed plus x plus cosine of x. And these problems are always a little weird, mostly because the x-coordinate that you're given here, x equals 3, is not an x value for f of x. It's actually an x value for the inverse of f of x, which means if it's an x-coordinate for the inverse of f of x, it must actually be a y-coordinate on the graph of f of x. So we're going to use that to help us solve this. But that's one of those things you just always have to keep in mind. So the first thing I'll do is insert a calculator page and define that function. So f of x is equal to x cubed plus x plus cosine of x. And then the problem told us to find the slope of the inverse, which would seem to imply that it has an inverse. But if you're not too sure about that, one of the things you can do is you can take a look at the derivative. So what I'll do is graph the derivative with respect to x of f of x. And you can see that this derivative is always greater than 0, which means that the function itself is always increasing, and an increasing function must be 1-to-1, so it must have an inverse. So that's good. And the next thing I want to do is, if you remember the problem, so it's the slope of the inverse at its x equals 3, which means I need to figure out when this function equals 3. So I will do that graphically. So I'm going to add a graph page. I'm going to graph f of x, and I'm also going to graph 3. And then what I want to do is find the intersection of those two. So menu, I like to use the geometry intersection points, just force of habit. So I get that. Okay, so I know that when the y-coordinate of f of x is 3, that means the x-coordinate of the inverse is 3. So the ordered pair on the inverse is actually 3, 1.13, blah, blah, blah. So what I'm going to do is I'm going to store this x-coordinate right here. I'm going to store that just as a. Okay, so now what I need to do is remember how to do the problem. So if I go back to the calculator page, the slope of the inverse is, well, let me find the slope of the function at that point. Let's go to calculus, derivative at a point. Since I stored it as a, I can just say that the value is a. I want the first derivative of the function that I stored as f. So that's the slope of the function at x equals a, but the slope of the inverse is the reciprocal of that. So this is the answer that I'm looking for. So the relationship between a function's slope and the inverse function's slope at kind of corresponding points is that they are reciprocals of each other. So this is the answer that I was looking for. And we're done with the problem. I hope that was helpful. Good luck.